everyone. Today I'm going to show you how you can set up a agent using Vertex's AI agent engine, and then trace that agent and observe it using Arize Phoenix as well as Arize AX. So if you're not familiar with Vertex AI Engine, what the AI Engine is it's a way to manage, deploy, and scale up your different AI agents in production. So it's a way that you can build an agent using an existing framework. So say you build with LangGraph chain or something like that. You can still build an agent using that framework. You can connect to different models. You can set up all your dependencies, and you can pass it over to Agent Engine, where that will deploy it remotely for you. It will allow you to manage them, scale them up in production. So kind of a management layer around agents that you build. So it is framework agnostic. So as I mentioned, you can develop your agents in whatever framework you're familiar with. So LangGraph, LangChain, AG2, other frameworks as well. And then you can access either Gemini models or models through the model garden. So you can access non-Gemini models as well. And then build the agent that you want to build from there. Then use the AI agent engine to actually deploy those agents and manage them in production. So it gives you additional tools like session management and memory management, some things there, as well as some built-in observability and evaluation tools. It by default will use the open inference standard that's been developed by Arize. And beyond that, you can do your own kind of observability as well. And I'm going to show one example of going a little bit further than the default using some tools within Arize Phoenix in this case. So I'm going to walk through an example that you guys can see, and you'll end up with something that looks a bit like this, where we've captured a few different runs of a LangGraph agent, and then we've automatically captured LLM calls as part of that. We've automatically captured tool calls and the responses from those as well. And you can see the whole thing's been still coded in LangGraph. All right, let's jump into the code. So here we have our notebook, and you can check the description below for a link to this notebook. This is an adapted version from Google's own notebook around building a LangGraph agent with Agent Engine, but we've added some observability features to it. You'll see it's pretty straightforward for the features that are added. That makes it really easy to trace. And so this will be an example agent built in LangGraph that has a sort of toy tool that you can use to see how that works, as well as some LangGraph orchestration code. So first thing we're going to do is we're going to install a few different packages over here. And so we're installing some Google Cloud AI Platform packages for Agent Engine and LangChain. We are also installing LangGraph, Pydantic, and then Arize Phoenix OTel, and Open Inference Instrumentation LangChain. So this OTel package is what will allow us to connect to Arize Phoenix. And then the Open Inference package is what's going to allow us to automatically capture telemetry data from LangChain or LangGraph in this case. So we'll go ahead and run that. And then depending on where you are actually running this file, if you're doing it locally versus in Colab, you may need to restart the kernel to use the updated packages. So that's what this next cell will do if you are using if you're using Colab, happen automatically. I'm just going to go ahead and restart my local environment. And then again, if you're using Colab, you can call this call here to authenticate your environment, which will make it easier to connect to the different Google Cloud services. If you're running locally like me, then you may just have to set up the Google CLI or Google Cloud CLI so that you can connect directly there. And then you're going to need to set a few different parameters here as well that are your project ID. So whatever project you want to use in Google within Google Cloud, your location, which is going to be US Central 1, for example, and then a staging bucket where you have a bucket that will capture logs and other information within Google Cloud Storage when your agent's running. So you can fill those in and then run the cell here. I'm going to do some editing magic to just keep those private for this video. Great. And once those have been set, then there's a few other connections to make here, mainly to Phoenix or Rise Phoenix in this case. So I'm using a cloud version of Phoenix that's free to access online. It's the same open source platform that you can access through our GitHub, but it's just available online to make it a little bit easier if you're dealing with hosting. You can also self-host the platform if you'd rather do that. So I'm going to open up my Phoenix instance, which you saw a minute ago, and I'm going to grab my API key here. I'll grab that, then jump back over and run this. And while we're here, just a little bit of what's happening. So we have a collector endpoint, which is pointing us to where we want to send our traces. So this is pointing us to the Cloud Phoenix environment. There's an API key that we use for Phoenix that gets passed in through a couple different headers here. The bottom headers here will be used if we're just connecting directly using Open Inference over to Phoenix. OTel exporter headers are also available depending on how you are sending data. If you're actually doing your own OTel collection, Phoenix is fully open telemetry compatible, so that makes it easy to connect. Great, and now we're ready to build your LangGraph app here. That's then going to be deployed on Agent Engine. So we'll import a few libraries there from LangGraph and LangChain, and then set up a basic tool here. Again, this is a bit of a toy tool. It's basically just going to return product detail information from a dictionary that's already loaded in here. You could obviously replace this with whatever you wanted to. One of the nice things about LangGraph and LangChain is that they make it easy to pass just base functions in as tools without a lot of extra information beyond a doc string. And now you're going to define a router here. And this is basically, or not even basically, this is a conditional edge that's going to be used within LangGraph. So this is basically going to take in a message here and then decide if there are any tool calls in that message. If so, then it's going to return get product details, which is a node to call within LangGraph. If not, it's going to end the conversation flow. So this is basically checking, does the model think you should call any tools? If so, we're going to go call those tools. That's the conditional part of this logic right here within LangGraph. And now you can bring all that together to actually develop your LangGraph agent. And so we'll run this and then I'll walk through what's going on here. So this is all kind of LangGraph setup at this point. It's not necessarily Google setup specifically. So what you're doing here is just creating a simple LangGraph app class here. And then within that, we have some setup functions. And this right here is the actual code that's being used to connect to Phoenix and Instrument. So we're importing register from Phoenix Hotel and then calling that with a project name, just what project will be used within our Phoenix instance. And then this auto instrument flag. And what that will do is it will look for any open inference libraries that are in your environment. And then if it finds any of those, it's going to automatically call them, which will instrument and capture any calls made to those libraries. So before we imported this open inference instrumentation LangChain library, that means that this auto instrument flag will cause us to instrument the LangChain or LangGraph libraries. And now you're defining which model you want to use for your agent, creating a message graph, again from LangGraph, and then binding your tool function here, your one tool function, to your model, and then creating a node within your graph that's going to represent tools here, or pass to from tools. And then you're going to create a tool node, which can actually execute the tools from there, adding that as a node, and then adding an edge from get product details to end, adding an edge as well from tools using your conditional edge here in the router that you defined above. So that's assigning that as a conditional edge. So now you have a LangGraph graph that's been created for your agent that can loop between those different LLM calls and then tools until you get to a response that you can send back to a user. And then finally, what's going to happen here is there's a base function that's being used to just make querying a little bit easier. And there's your whole LangGraph agent set up. That's all been created and set up. And so next step here is you can just call that setup function to define that. And you should see output that looks like this, where you're seeing the actual connection made here through to Phoenix. And now your agent's good to go. You can make whatever calls you want to here, and you should be able to connect through and get a response there. And if I jump back over into Phoenix, I can see I have a new entry here with that same get product details for shoes query as we go through, and you're automatically capturing the start node that gets called, followed by the logic here to decide, okay, we're going to go from start to tools. Now we go to our tools node, and that's actually what's calling the LLM call here through to chat Vertex AI to get an understanding of which tools should be called. So you can see it comes back with get product details to call shoes. You can see then we're going to go from this current one to our router edge here, which is going to decide that we should go to get product details as your output. That then goes to get product details node in this case, which calls our tool there, and then finally decides to return back from there. You can see the full execution. We could then take this further. We could add evaluations to this. We could add this to data sets for further experimentation or whatever we wanted to do from that point on. This video is not as much about going further there, so I'm actually going to show you a little bit more within deploying this LangGraph app as part of your agent engine through Google. And so all you have to do to do that is use agent engines here, and you're going to create your app, in this case, with a project ID and location. And then you're going to define whatever kind of package requirements you have. So just the ones being used above here. So you can go ahead and start that while we're talking. And so we'll pass our same dependencies in here, and then you set a display name and a description. Now, if you go through to this URL here, you'll see that actually happening live as it goes and actually sets up your agent engine. This takes a minute or two, so I'm going to skip ahead until we see the end. So now once your service finishes deploying, then you can either access it again directly from here using the same syntax as before, this time just calling your remote agent, Otherwise, you can also access it publicly now because your agent's hosted. It's available to access throughout the internet from other services that you might have. So now you have a publicly deployed agent just like that, just as easy as it goes. So hopefully you've enjoyed this little bit of a hello world into how you could combine LangGraph, Arize Phoenix, and then Google AI agents engine here to deploy and access agents very easily and very quickly and observe them as you go. We'll see you next time.